Okay, Emily. Determine the first problem. Determine the equivalent positive standard position angle for each negative angle listed. Negative 98. Now, positive standard position. Do you understand the meaning of positive standard position?
I
That
think so.
yeah. So that means when you come from the right hand side, like when you, for example, if your terminal arm is, let's say it's somewhere here, then standard angle or the primary angle is gonna be that one, positive direction, right?
Mm-hmm.
Positive. You can approach it from negative, it's just gonna be like that.
Yeah.
And yeah, so they're asking us to find the positive one from the right hand side. So and that is for negative 98. Determine equivalent positive standard position for negative 98. Now, where will be your negative 98? Your negative 98, let's do it here. I make reference plane. Sorry, I choose another color. Okay. And negative 98. So we know that negative 90 is going to be right there.
Mm-hmm.
This arm is representing negative 90, right?
Mm-hmm.
So we need more than that. We need 98. So your arm is going to be a little bit on the left hand side.
Yeah.
I mean, somewhere there.
Tiny bit.
Yeah. So that is 98. And it's negative direction, so you're going to put a negative sign. So clockwise is negative, and you can approach or you can measure it from the anti-clockwise direction.
Mm-hmm.
And anti-clockwise, we call it positive. And in order to find the angle from this side, we have to find this whole measure.
Mm-hmm.
And in order to find that measure, we have to do 270, which is going to be right here, minus this tiny angle that we have right there. Now, can you tell me what is that tiny angle right there?
8 degrees.
Good. If that is 8 degrees, what would be this angle from here to there?
270 minus 8.
Cool.
So 262.
And that is going to be a positive because you're doing anti-clockwise, right?
Mm-hmm.
Positive. The reason is because it is an anti-clockwise rotation. And now let's look at the other problems.
I don't know what happened to the number or B there, because that whole thing is kind of screwed up.
B
So I
part?
don't. Yeah, that's like I don't know where the number 2 solve for the domain came from, because the B is like separated and squished down.
You mean that part, right? You're talking about that.
Yeah, that's only a section of the equation.
Right. So this one they're doing 360 minus this black part, this 98. That is still
Yeah.
gonna give you answer because the whole circle is 360. 360 minus black part, which
Mm-hmm.
is 98, is still gonna give you this red angle, the
Mm-hmm.
standard angle. Either way, it's right. Okay, so the B part is a negative RA equals to.
No, I don't know what happened to that question. It doesn't look like that on my screen at all.
So there's nothing actually, right? So which
Yeah, I don't know what happened there. Is
let's
there a way for
see.
me to copy and paste on somewhere?
I didn't see anything. Can you tell me the statement?
Okay, it's negative um, pi, or I don't know how to I don't know how to word these questions, or these equations. Negative pi
Mm-hmm.
divided by 3.
Yeah, that's it.
Yeah.
All right, so pi, we know that pi is a radian measurement. Pi radian is equivalent to 180 degrees. So those are the degrees, like we have temperature in degrees Celsius and degree Fahrenheit, right?
Mhm.
So in the
Mhm.
same manner, for measuring these angles, you can use the radian format or the degrees. And we know the pi means 3.14 radians, right? That's the
Mhm.
equivalence. So you can remember it that way. Approximately 3.14 radians are same as 180 degrees. So now we can break it down. We can figure out that angle in terms of degrees, because degrees make more sense to you. Pi means 180 degrees divided by 3, right?
Mhm.
Which
Yeah.
is,
Is there a way for me to copy and paste on there
what do you mean
at
copy
all?
and paste?
Like, cause I have my assignment up right here. Just cause I don't know what happened to it on that screen, but it's
So
just so that I
you
can show you what I did.
can you see my screen right here?
Yeah, it's just it's all wrong. Like, I don't know what happened to the file, I guess.
Okay, I see.
You
So
know what I mean?
you mean this file is not showing all those things?
Yeah, no, it's not right at all. It must
Okay.
be a different version of Word or something.
All right, let me open the full file because I just opened some part of that.
Oh,
And
you know what it is? It's because I was using, you know how you use the equation
yeah,
thing in Word? Yeah.
let me see if I can open it in documents, then I can edit it right away. And yeah, let me see. It's loading, right? So
Yeah,
probably it's
yeah,
gonna.
it's loading all the little equations that I did. There we go.
Mm-hmm.
That's better.
Cool, cool. Now it's showing all those things, because that was like um, kind of smaller file version. They call
Hmm.
it. It's kind of different format. Now we have all those angles. So the question was. So it's not a B part. It's kind of.
It is it is B. I don't know why B jumped down there.
Oh, B is jumping down there,
It's
right?
not like that on my thing. Yeah,
Okay.
B. Yeah, that was the minus. How do you say that?
Which one? Let
The
me
minus.
Let me, there's another way of doing it. I can download the file and like download, and then I can open this thing in my Word, and that's gonna be perfect. I mean, all the old values. Um, are you happy now?
Yeah, that's
Cool.
yeah. How do you say that? B. What, that little equation there? How would you say that?
That equation,
Yeah.
that's negative pi over 3, or
Oh,
negative
okay.
pi third, pi over 3,
Okay.
or pi divided by 3.
Okay.
And now in order to convert it to the degrees, now that looks kind of, it's okay, it's not a big deal, but it's more obvious if you just write pi, replace pi with 180 degrees.
Mhm.
Negative sign is gonna stay there, and the pi radians are equivalent to 180 degrees. So you replace it with that divided by whatever number you had, and you get your answer, which is negative 60. Now
Mhm.
your procedure is exactly same as you have done in that case. So let's do it. Probably we can do it here. We have enough space. um, negative 60. So in order to make negative 60, you're gonna go down here. Looks like 60 now. And negative rotation is clockwise. So this angle is negative 60 degrees. And we have to do positive standard position. Standard position means you approach this arm, terminal arm, from this side, which is anti-clockwise. Let's use another color for that. Right. And we know that the whole circle is 360. From this point to that is 360. So 360 minus that that green part is gonna be your standard angle. So you do 360 minus 60, which is 300, right? Which is good. All right, so that was that, and that's everything. Now you're writing theta. Is it related to the next problem? Solve for the domain?
No, go back to the other one. Yeah.
Oh.
see how different it is?
Yeah, I see. All right, so let's pick that one, and
That's pretty cool thing.
pardon?
That's a pretty cool thing.
Yeah, the technology is so advanced. Pick things, place wherever you want, and do whatever you want to do. Even I can write here if I want. I can write there in a Word file.
Oh, that's really cool.
Yeah, so they have all option in Word. Even you can do editing, but that is gonna be shared with you automatically. That's why I'm bringing things to the notebook.
Yeah.
So everything is in the notebooks. Yeah, they're training students to use these things. In next 10 years, the paper notebooks are gonna eliminate completely.
Yeah,
So
well, that's good.
It's gonna be everything digital. Yeah. All right, Emily. So we have number 2, solve cotangent, which is 1.6 for that domain. Now, that is one complete circle, right? Cycle.
Yeah.
And they gave you cotangent 1.6, which is you're writing there. It's right. And then you do 1 over tangent. Right. Tangent inverse of that is 32 degrees, right?
Oh, yes.
And now solve that. That means you have to find angle. So one of the angle that we have is 32. Now, what is that RA and SA?
That's in the course, that's the formula that they gave, and they like when you show the formulas that you use before putting the things in.
I see. So
yeah, it's just something that they like to see.
but you
in
don't
the
have to do
assignments or
that.
whatever.
Yeah, it's pretty straightforward even without. And we know that's 32 degrees, and 32 degrees are in first quadrant, which is gonna be somewhere here. So now that's 32 degrees, and we know that we're talking about tangent, and your tangent is positive. And tangent is positive in first quadrant, add sugar 2. Tangent is going to be right there. So you can extend the same line opposite and make a kind of little triangle there. So one of the angle is that, and the second angle is going to be this one. So now we figure out what is that measurement, which is running from here to there. So in order to measure this measurement, you're gonna do 180 which is from here to there, minus 32. So that's 180. So we do 180 minus 32. No, plus
Plus
32,
32.
yeah, because
Yeah.
we're going over. So that is that. And you did the same thing, but that is not, I don't know, right, ASA. So if you understand that, it's alright. If you don't understand, you can write it the right way with the diagram. Make a diagram, and
Okay.
then in the exam, you can write this one as an angle. So theta equals to this one, and theta is also equals to 32. So you
Okay.
can name them theta 1, theta 2, but if you just keep theta, that's still acceptable. So you have two theta values, which
Okay.
are going to make tangent equals to that. So
Yeah.
tangent of 32 and tangent of 212 is equals to the same number.
Mhm.
Alright, so that was number 2. So the domain that they gave you is within 0 and 360. Sometimes they're gonna ask you bigger domain, like 360. Instead of 360, they're gonna write 720.
Mhm.
Find the theta values for all domain values within 0 and 720. And if you have 720, that means you're gonna do 32. Then 12, what was that? 12, yeah, 212, right?
Mhm.
That's within 360. And if they write 720, what we're gonna do, we do this one once again. So we do this move. We go from here, right? That's the third angle. And the fourth is gonna be,
Oh.
yeah. So you
Hmm.
keep rotating. Every time you do extra rotation, like if you look at this one and this arrow, you did 360 plus whatever angle, that was 32.
Mhm.
So if your limit is 720, then you're gonna do 2 pi, like 2 rotation.
Yeah.
So the first one, and then the second with the same, right here, then you do, and the third one is gonna be that one.
Hmm.
So I hope that makes sense to you.
Yeah.
Right. Now number 3. How many options do you have? You have, sorry, three part for that.
Yep.
Right. Use the unit circle to evaluate the following trig ratios. Sine 90 for 90 degrees coordinates in the unit circle. Yeah, that's right. So the unit circle, now in the unit circle, your radius is gonna be 1, right?
Yep.
So 1, y value 1, x negative 1, and there y is negative 1. And you can draw a circle if you want there. Right?
Mhm.
And that point has a x coordinate 0. X is 0 right here. X 1, 2, and so on. So
Mhm.
this point is 0, 1. That one. And with respect to that point, we're gonna have angle 90 degrees. So you unit circle for sine 90 and sine 90 according to, now if you look at that, the triangle, normally when we make a triangle like that, sine 60 or 45, we do opposite divided by hypotenuse, right?
Yeah.
That divided by this larger side. But here, what kind of triangle we will have? In this triangle, this side, this point is basically moving towards that. When this point reaches there, this triangle is going to be really kind of, this side becomes equals to that one. Do you agree with that? When
Yeah.
this point moves there, the triangle is going to look like just a straight line. Why? Because your opposite side and hypotenuse becomes same. Hypotenuse. So opposite side and hypotenuse, they become equal. And in a unit circle, we know that now if that length, which is right here, this line from here to there, is representing both of them, it's representing the opposite and hypotenuse, then we can write 1 here. Opposite side is going to be 1 and hypotenuse is going to be 1 when you go right there, when this point approaches that point, right?
Yep.
And by doing that, the y is going to be 1 and r is also 1, and that's right. So you can add up this extra information in that, but the logical reasoning that you're using is right. Y coordinate is 1 and the r is going to be 1. This triangle is just look like a straight line.
Yeah.
And then the b part is cos pi. For 180, the coordinate of that is going to be that, so x is that, y is this. Good. So you're just using pure logic. In the same manner, in this case, your triangle is going to be just a kind of, straight line. So makes sense. So that is -1. And then 270 is going to be right there. And the triangle, the r is always positive radius, and the y is -1 this time, so -1. That's good. And number 3. You can make diagrams if you want, like as I showed you in the first case, A.
Okay.
So you can make diagrams for B and C. I don't know if you know how to make diagrams in the Word. Are you using Word software?
Yeah. I don't know what. I don't think I have that version though. That good of a.
It's not that hard though. You can click picture by your cell phone, make a diagram on your paper, and then that picture you bring it to your laptop, copy it, and paste anywhere here.
Oh
Right?
yeah. Yeah.
You can paste it anywhere in the file. That's the way to. So you send them the PDF file or the Word file.
The Word file.
Okay. That is that. Number 4, convert. Right. So from degrees to radians, 220, and you times it by pi over. Now let me write down the reasoning behind it. So we have 220 degrees. So we want to convert it to, let me go to the next page. We want to convert it to the radians, right?
Yep.
The radians. Now you have to know the conversion that 180 equals to 180 degrees equals to pi radians. Now if I divide both sides by 180, I get that. That means 180 over 180 equals to these many radians, and 180 divided by 180 is going to be 1 degree, right? Just 1. So 1 degree equivalent to that. But the question, according to the question, we have to find 220. So 220 degrees in radians. So we multiply both sides by 220. Multiplied by 220 rad. Now on the left hand side we have 220 degrees, and on the right hand side we left with 220 over 180, and you're gonna write pi in the end. So you can simplify this thing, and simplification is pretty simple. You divide top and bottom by 10, so zeros cancel.
Yeah.
Zeros cancel out, and we have 22 pi over 18. Now both of these numbers, they have 2 common. 2 is a common factor of 22 and 18. Divide them by 2. So we got 11 pi over 9. And you have to write radians. So we call it unit law or unit rule. You convert into unit. You just start from there. You have 180 equal to pi radian. Convert 180 into 1 by dividing both sides, and then multiply with the number that you want to convert. Right? Multiply 220 on both sides, and then you're gonna get your answer on the right hand side after simplification. Did you have the same answer?
Yep.
Good. Yeah, you didn't show them the simplification, but it's all right. It's acceptable. So that is that, and now 28. So you can memorize this thing if you just want to use the formulas, and if you want to show them logically or for your understanding, this is the logical procedure of converting degrees to the radians.
Yeah.
Logical process. That is that. And let's see. Now the same thing, we're gonna use the same rule for 48. Now convert the radians to the degrees, and now you're gonna flip it. Rather than multiplying with pi over 180, you're gonna multiply with 180 over pi, and then you cancel the pi with pi, and you get the answer. And I think it's right. Let me do my calculation. So you cancel pi. Let me bring it probably to the next. Right, so we cancel pi by pi, and 180 and 4, they have a common number. Like you can divide them by 4. So 4 divided by 4, 1. 180 divided by 4 is gonna be 45 degrees, right? And now at the bottom we don't have anything. Multiply. This x is, it's a multiplication, right? It looks like x.
Yeah.
So you did by mistake, you wrote x. So it's cross times. Now you times that with that number, and you're gonna get 135.
That's cool way of doing it.
Yeah, so that's right. Now the next one is 1.5. So you times it with that, and now, yeah, there we don't have, there we had a pi, and in this case we don't have a pi. So in that case you're gonna have pi at the bottom, and you have to write down the value of the pi, and then you divide it by pi, and I think that's right. We can use calculator for that. That number was 278. Yeah. And probably added a mistake. Let me redo that. 1.5 times by 180. Yeah, that's right. Divided by pi. So we got 85.9694, which is approximately equals to that. That's good. Makes sense. Related acute angle for that. How many questions are there?
A million. If you want to just go, there's some ones that I left blank that I feel pretty confident about the ones that I've done. But there's let me see, there's some questions that I just, the way that they tried to teach it, I just could not understand. Where are we here? Okay, starting at question 11, using the compound angle formulas, right there. There's the questions that I didn't get. Right, yeah, 11. They didn't really give very good examples of how the compound angle formulas work, so I kind of got lost.
Right, so these are your answers. Number 18. No, you didn't solve them yet. Okay.
I did some of them. There's a couple that I left blank that I didn't really get. So starting at 11, yeah.
All right, so let's have fun with them. Number 11. So according to number 11, we have to determine exact value of cos. Right. Exact value of this thing. Now, the process according to the logic, you can break down 11 over 6 in such a manner so that you have a whole number and some fraction. So this is an improper fraction, right? So you convert into a mixed number. Now we know that in order to convert into a mixed number, you have to know 6 times what number is very near to that, and we know that that's 2. So you can do simply that. 6 times 2 plus 1 is 11. Or if you want to do it in a more slower way, you replace 11 with 12 minus 1.
Okay.
Then you do 12 divided by 6 minus 1 over 6. 12 over 6 is 2. 2 minus 1 over 6. Right? So you can convert it that way. So we have a pi with that, so you have pi everywhere. So you have pi. So we got 2 pi minus 6 over 1 over 6 pi. So by using this thing, you can break down this number in terms of these two numbers. So 2 pi minus 1 over 6 pi, or pi over 6. Now the next thing, cosine 2 pi means 360. So you go one cycle, one circle. So after completing one circle, you go forward this much. And what is pi over 6? Pi over 6 means 30 degrees. So you go slightly in the first quadrant. So therefore, from here to there is going to be 360. from here to... Sorry, we're doing minus. Wow. Probably I'm sleepy. Okay, so no, we're not going in the second, first quadrant. Rather, we are returning back
Yeah, yeah.
by subtracting.
Yeah, okay.
So 360 minus this much, which is 30 degrees. So we
Yeah.
erase that part. Now, that is the fourth quadrant. And we know that the cos of this angle is going to be same as cos of this angle. This angle. So we will find the cosine of this. I don't know what color is that. It's a blue, right?
Yeah.
Is it blue?
Yeah, like teal or aqua or something.
Yeah, we call it shardai in Punjabi. Yeah, that's a different
Oh.
color. So that color is representing 30 degrees. So according to the logic, cosine of this angle is same as cos of pi over 6. Cos of pi over 6. Cosine of that is equivalent to that one, right? It's the same thing. Like we make a triangle, for example, second quadrant. In order to find that, you do evaluate the trig ratios for that angle, right? And then you consider the signs as well. If your signs are positive, you put a positive sign. If it's negative, you put a negative sign. Now we know that cosine is positive there. According to add sugar to coffee, that's gonna be positive. So you write positive sign there. And replace this angle with pi over 6.
So
Is it good?
yeah, is that what the compound angle formula is? What is that?
You can use compound angle formulas, but that's kind of more straightforward. You can use cos A plus B equals to cos A cos B minus sine A sine B. Did they teach you those identities?
They were trying to, but I didn't get it.
You can
I was
use
having a
them,
problem,
or use this diagram. Write this equals to this thing, and then write this step plus cos pi over 6. And cosine pi over 6, you can use special triangle. Cos of 30 degrees pi over square root of 3 over 2. So you can write square root of 3 over 2. So that is the value of that, and that's the exact value. And how do you know that? By the special triangle. Now, special triangle means this angle is going to be 60, right?
Yep.
And this side length, we call it 1. And the R, largest side, is hypotenuse, which is going to be 2. And that is 90 degrees. So adjacent is going to be that. Square root of 3 is the adjacent. So cosine of this angle is equals to adjacent divided by hypotenuse. So adjacent is that, and hypotenuse is 2. So by using special triangle side lengths, we do that. So the 1 is gonna be opposite to the smallest angle, which is 30. This angle is 60, and largest angle is 90. So the largest side is gonna be 2, and it's opposite to 90 degrees. So by using special triangles, we found exact value of that.
Is the 3 squared over 2? Is that what
Yep.
it? Yeah. Okay. Okay.
So second thing is, if you want to use the formula, you can use that. Let me write down the formula for that. So according to the formula, cos A plus B equals cos A cos B minus sine A sine B. So you can use this formula if you want to use it. Substitute the values. Now what is my a? According to that statement, cos a is 2 pi minus b is pi over 6. Now if you have minus there, you're gonna put positive sign right there.
Okay.
If you have positive sign, you put negative here.
Okay.
Negative, then you're gonna turn into positive. It's kind of opposite. So, and that's the kind of rule or formula for the cosine double angle. And now by using it, that's my a, and that is my b. A minus b. So I do cos a cos b. Using that formula is gonna give me cos a, which is 2 pi, cos b, pi over 6, positive sign, right? Positive is going parallel to the negative sign. So sine a, sine 2 pi, sine b is pi over 6. Now, cosine 2 pi, what is cosine 2 pi? Do you know the graph of cos?
No, and I think that's where I got confused with these questions, because all of a sudden they just started putting in numbers, and I'm like, how did they even get those numbers? They never taught me how to do that.
I see. Let me
Yeah.
teach you the graphs of the cosine in order to understand it more thoroughly. So the cosine.
Or you mean like, oh, do you mean like the loopy things? Like
Yeah, that.
the rotation in a line?
Yeah, that's true.
Yeah,
Graph.
I know those graphs, but I don't know how to get those numbers. I don't understand how to get the numbers.
All right,
But
I'm gonna share.
I know what a cosine graph looks like and a sine graph looks like.
Yeah, sine starts there and cos is gonna start there, right?
Yeah,
So,
yeah.
so what we do, we write down a couple points like 90, 180, 270, 360. Now you have to remember that sine. Let's do sine first. Sine 90 is 0, and sine 0 is 0, sine 90 is 1, and sine 180 is gonna be 0. So the points that we're getting are right there, here, not here, there, right? These are the main points, and that's gonna give you -1 and then there.
Yeah.
So your graph is gonna start from there and go all the way up, and comes down, and it keeps going like that. So the minimum value is -1, plus 1 is the max value. And in this question, we are interested in 2 pi. And 2 pi is right there. So at 2 pi, we have to find cosine, not a sine. So let me draw the cosine. Cosine is going to start from there, going to meet right here. These are the main points. And then it goes here, there, and then top. Cosine 0 is 1. Cosine 90 is 0. And 180 is going to be -1. 270 is 0. And 360 is 1. So we got 1. So you're going to substitute. So you have to know these two graphs, which are kind of really important. Keep going. So that's the kind of important points and their uh, movements. So sine and cosine are same kind of graphs. It's just their location. If you
Mhm.
move red graph, shift it 90 degree to the left hand side, it's gonna turn into the blue one, right?
Mhm.
So sine becomes cosine if you move it to the left hand side, and if you move cosine to the right hand side, like blue to the right hand side, by 90 degrees, then it's gonna turn into the cos. So that graph was important, and you can write down the answers. Cos 2 pi is 1, and cos 30 degree according to the special triangle is that, and sine 360 is 0, the red graph.
Okay. Yeah.
So you substitute 0. 0 times by anything is 0, so we got that number times by 1. So that's your answer.
Hmm. So how do you oh, it's by the special triangles. So the special triangles, do they have those numbers for like 30, 60,
Yep.
90?
Mm-hmm. So whenever you have a 30 degree, whenever you want to find 30, you're going to make 30, 60, 90. When you have 45, then you make that isosceles triangle. In isosceles, you make 45, 45 degrees, both of the angles.
Mhm. Okay.
So that was that, and now we have these problems. Which one do you want to do?
Um Number 14.
Number 14. Alright, so solve that for intro. Right. Did you like online more better? More convenient?
Yeah, it's good.
Yeah, you don't have to drive, don't have to spend time, right?
Yeah. Yeah, it's pretty far.
uh, yeah, you were talking. How far was that? It's
um
another city or?
No, no, no. I live down Commissioners in Adelaide.
Oh yeah, you
Yeah.
told me. That's pretty
It's
far.
it's it's easy, you just go up Adelaide, but still.
Mm-hmm.
Especially
Yeah, it's
rush hour, it's kind of
yeah, that's true. Sometimes it takes like, double time. I mean, it's 15, probably 20 minutes drive, and
yeah.
it can take 40 minutes if it's rush hours, yeah. Yeah, so technology is making life easy. And
Mhm.
it's gonna be recorded there. You can watch it any time. Probably your kids can watch them in next like 13, 14 years, right? Yeah, like how the mom learned and all that stuff.
Yeah. Except they're going to be
That's
learning
amazing.
this in like second grade probably.
Not a second grade, I mean the quality of learning is decreasing. I mean the school system is
Really? Oh.
decreasing. I mean yeah, it's more easier to study nowadays, but students are not really into the study. I mean there's less motivation. There are
Mm.
more distractions, video games, and all that kind
Yeah.
of stuff.
Yeah.
That's true. And with technology, things are getting easier. You have more access to these resources and the education system, and on the same time, the the technology and the media and all those things are increasing, and the kids are more vulnerable to those
Yeah.
things, video games and stuff like that.
Mhm.
That's true. So that is solve that for that system. So we have that interval. Determine the values in radians. All right. Okay. We have sine squared, and there we have cos, and that means we have to convert them into something more simpler. And I know that sine squared x is equals to 1 minus cos squared x. And just turning off unnecessary things. So by by using that, you can convert that to this form. And in this form, we have cosine on both sides. So you
Yeah.
move them to the left hand side. So you're going to get positive cos squared x plus 2 cos x negative 2 negative 1 equals to 0. So you move 1 and cosine squared to the left hand side. So we got that equation. Now you have to solve it as we solve the quadratic equation. So you can do a conversion. You can convert or substitute, put cos x equals to, let's say, y. By doing that substitution, your equation right there is going to turn into this form, which
Mhm.
looks pretty simple and easy.
Mhm.
And we call it quadratic equation. So we have power 2, maximum power is 2, and we call it degree 2. So in degree 2 equations, we're going to use quadratic formula, or we can do factorization. In order to make factors, you have to find two numbers which add up to the coefficient of y,
Mhm.
and the same numbers should multiply to the coefficient of y squared, which is 1 times by that means minus 3. So which two numbers times to the sides and add up to the middle one. Now we start by the multiplications. 1 and 3 is 3, right?
Yep.
But we need negative 3. And on the same time, my sum should be plus 2. So that means I
Mhm.
have to make minus. We have to convert that 1 to negative. Negative 1 plus 3 is 2. And multiplication is that. Now, once you have that, you're going to use a shortcut or simply break down the middle one in terms of the numbers that we have found there. And the numbers that we found are negative 1 and 3.
Mhm.
So we replace 2y with these two.
Yeah.
And then you take factors from first two and the last two. In first two terms, we have y common, so write y out. Factor out y, and we have negative 1 inside. There we have plus 3 common. Sign is really important, so you have to write sign
Yeah.
in the second time. And now, whenever you get same numbers, same factors like y minus 1, y minus 1, if you get the same factor, that means everything is good so far. If
Yeah.
you don't get them same, that means you're doing some mistake. And the final step is factor out whatever you have in common. So we have that part in common, so we factor it out.
Yep.
And we left with these two, and we write them in the next bracket, the remaining multiple terms. So we got that. And now you substitute your real value back. Now y is, we can do that later. Let's find out all the y values which satisfy that equation. So what y values satisfy that? 1 and minus 3, right?
Sorry,
If
I
y,
don't understand. Oh, yeah, y equals 1 and y equals
yeah.
minus 3.
So if you substitute y1 in that equation, it's going to turn it equal to the right hand side, which is 0. And if your y is negative 3, it's going to turn into 0. So those are the answers, but it's not the final answer. It's just the answer of that equation that we were solving. Now we substitute the value back substitution. Y is cos x, right? We have to solve that equation. That's the target.
Yep.
So cos x is 1. Therefore, or minus 3. Now you have two separate equations and you have to solve them. Now we know that cos x is positive, so it may lie in the first quadrant or the fourth quadrant. And we know that cos 0 is 1, right? That's the cos 0 is 1 or 360 is 1.
Yep.
So the first is just a line itself, and the second is going to be that. So x equals to, therefore, x equals to 0
Or
or
360.
360 degrees. And the answer should be in radian. So we write 0 radian, RAD, and 2 pi radians. Now, in here, cosine is negative and it's negative 3. You already know that cosine starts from 1 and it goes down here.
Yep.
And then negative 1, and it just keep moving like a snake, like
Yeah.
that, right?
Yeah.
So that snake stays within that limit. 1 minus 1. It never get any value bigger or smaller than negative 1 and 1. These are the bounds. But there they're showing, or this result is giving us negative 3, which is going to be down there. So this is a base function, and according to the rule, it should stay within that range.
Yeah.
It cannot obtain that value, so that's redundant. So we discard that case. So we discard it because it's not possible.
Okay.
So your answer is going to be that.
Okay.
Alright, so I think my time is already up. It's 45 now.
Yeah.
Yeah, so this is already uploaded there, and you can go to the YouTube channel London Math Solutions or londonmathsolutions.ca. I'll upload my video there.
Okay.
And you can watch it whenever you want to watch. Let me stop the